Hey guys, and welcome back to another video on the channel. In today's video we're going to be proving this trig identity slash question. We're going to be showing that this entire thing is equivalent to this entire thing here. So ideally we want to make the left hand side look like the right hand side, so we don't want to be switching back and forth, even though that's a lot of what people would do. You actually have to make one side turn into the other side to prove it properly. Even though they'll both prove the same thing, you pretty much got to turn one side into the other. So what we got to do is pretty much just take a look. We want to turn the left hand side into the right hand side. So all we're going to do is take a look at what's common at the top there. So we can see we've got a sec theta and a sec theta, so we can actually take that as a common factor pretty much. So we'll go sec theta taken out, and you'll have 1 minus cos to the 4 theta. Okay, and then we're going to have 1 plus cos squared theta. So that's equal to sine theta tan theta. So what's interesting is this particular term here. Now the reason why that term's interesting is also because of this term here. You can actually rewrite this term as a difference of squares. So for example, if we had 1 minus a squared, we can rewrite that as 1 plus a multiplied by 1 minus a. Because if you were to multiply that out, you get 1 minus a plus a minus a squared. So you get 1 minus a squared. So in this scenario here, what we technically have when we have 1 minus cos to the power of 4, what we technically have is 1 plus cos squared multiplied by 1 minus cos squared. Now the reason why that's useful to us is because, well, for starters, you can recognize this guy and this guy right here. So if we were to substitute that in, we'd have sec theta multiplied by 1 plus cos squared theta multiplied by 1 minus cos squared theta all over 1 plus cos squared theta. And we can see straight away we can actually cancel that out. So what we have is this is still equal to sine theta tan theta. And now we just scroll down. What we have is sec theta multiplied by 1 minus cos squared theta is equal to sine theta tan theta. Now that makes it a lot easier to work with. What we're going to do is work out pretty much what happens when we expand this as well. So sec theta is 1 over cos theta. So that's going to be important. So technically when we expand this, we're going to have 1 over cos theta minus cos squared theta on cos theta equals sine theta tan theta. We can see one of these terms is going to cancel. So what we're going to have is pretty much 1 on cos theta minus cos theta equals sine theta tan theta. Okay. What I'm going to do is try and combine these two together. So, well, for starters, we can actually not cancel these terms here. Well, we technically can, but it's not going to be in our best interest because we want them to have common denominators so you can combine the two together. So if I actually just re-erase that last step and combine them on one fraction, we'll have 1 minus cos squared theta on cos theta. Okay. Now, what we technically have at the moment is pretty much the top is a different version of Pythagorean's identity. So Pythagorean's main identity is sine squared theta plus cos squared theta will be equal to 1. So what we have is sine squared theta is equal to 1 minus cos squared theta. So what we have here, this top bit is just sine squared theta on cos theta. And that's equal to sine theta tan theta. Now, if I actually take out a factor of sine, I'll have sine theta multiplied by sine theta on cos theta. Now, sine theta on cos theta is tan theta. So I can replace that with tan theta. So I'll have sine theta tan theta is equal to sine theta tan theta. So all I did was substitute this guy because I know sine theta on cos theta is equal to tan theta. So your left hand side is equal to your right hand side. And that's how we prove that trig identity. I hope you enjoyed this quick little video. Give it a thumbs up if you enjoyed it, and like and subscribe.